Hello and welcome everyone to the WebSphere Performance Tuning webinar. My name is Onali. I'm from Royal Cyber. We'll get started in 1 minute. If you're not able to see the presentation or not able to hear me clearly, please notify me in the chat. Okay, I think we'll get started. So today's agenda is I will go over give a quick overview of our company, finding root causes of resulting poor performance, deliver applications with high load testing and tuning, and go over some of the use cases. Company overview. We are based in Illinois. We have worked with many Fortune 500 companies since 2002. We offer cutting-edge IT services globally, and we have presence in Europe, Middle Eastern, and South Asian markets. Why Royal Cyber? We have won the winner of Impact 2003 Mobile Innovation Award. We have this smarter commerce authorization that allows us to be solution providers with IBM Smarter Commerce. IBM business partner for around 10 years. Team of more than 200 highly skilled IT professionals. 10 plus years of extensive experience in WebSphere brand solutions. We have our headquarters is in Chicago, Naperville, and we have branches in UK, Australia, Middle East, South Asia, and India. So performance improvement, the most important element of e-commerce application is to provide quick response to customers. And as part of the e-commerce application, there are multiple tier environments, which is also integrated with external applications. The multi-level architecture makes it complex to determine the bottlenecks, and also makes it important to remove bottlenecks to improve performance. There are various clusters of web servers, app servers, search servers, and databases where the bottleneck can exist. And in this presentation, we'll basically go over some of the ideas on how we'll go over the process of how to identify the issues and create implementation plan to resolve those. So as part of the performance element, I mean, we could categorize the web performance in 3 levels: server response time, network latency, and browser rendering time. So all of these, I mean, the bottleneck, performance bottleneck can be from, is basically can be from any of these. So we will, so The server response time is basically the time when the web server receives a request, the application server processes a request and sends the data back. So that's the server response time. The network latency is the transfer time between the web server to the browser. And the browser rendering time is the time it takes for the data comes to the browser, and the browser actually renders the executes all the JavaScript code, they loads renders the data on the website. So we will basically going through all of these to as part of the analysis. We have to go through all the three areas to find out where the performance issues are occurring. So as part of the performance tuning process, these are the high-level steps we need to go over. So first is get basically the requirements, get the environment details, get document the requirements, create the finalized requirements based on your caching requirements, your search requirements, load requirements. Basically get to know the environment, set up scripts for load testing, analyze the data, monitoring from the test reports, and then using different tools to analyze the data from the different layers. Create reports with details on proposed changes, which is basically the implementation phase, and execute performance tuning and configuration. So these are high-level steps, and we will go over these in the next slides. So requirements gathering is we are basically getting to know the environment. It can be commerce environment, commerce environment, or any other application server. Getting to know the application server instance, how the clusters are set up, how many web servers, Solar search engines are set up, the staging environment, QA environments, how many catalogs are set up, the volume of data, peak hours, how many concurrent users are there, how many page views are done. And as part of the requirements, we also have to get requirements on the different language-based search. From search perspective, what are different collect data from search data loads, and then the first phase after the requirements gathering is collecting, doing performance testing, perform load testing in the QA environment to capture statistics to start analysis. And as part of the analysis, as part of the performance testing, we have to create automated scripts based on the requirements which were created, which were taken earlier, and then schedule workloads, execute the test cases, and that basically gives the data for analysis. This slide shows some of the reportings which are collected from the RPT, which is the Rational Performance Tester. So this shows how much each of the pages, the response time is. This gives us, helps us identify when the load increases, and you can do load-based testing or longevity testing, like based on duration. What is the impact on the server after the load, or the time-based testing, how the server behaves. So after during the analysis phase, we can go over the different server, the application servers, HTTP servers, all the statistics, how much load is the load getting balanced between from the load balancer to the all your different servers, doing analysis on that. The browser rendering time, there's tools available which you can monitor browser rendering time, response time, network latency, wait time, and caching. So this is one of the snapshot of one of the analysis. It basically shows how much time took on the server side to process the request, how much time is from the transfer time is the network latency time, how much time it took for the wait, from the wait perspective, and see in this so each of the page in each of the page, all of the objects, what is the size of each of the objects, as well as the time chart feature basically shows. So suppose if in your page, if you had about these are in the red, it shows all the pages, all the objects which are which is trying to load. So if you have, the browser has a limited number of connections. So the first set, it's trying to download all these images, and all the ones in the gray area here shows the one which are waiting for to be loaded. So this basically tells us that for some of the images, we can basically add them in the cache, or that can improve performance. So the browser has limited connections to get all the images loaded. That's why we can basically analyze on the wait time, and then improve performance on that. So as part of the implementation phase, we can analyze the load balancing, the server side and client side caching, DB cleaning activities, and then from the browser rendering side, I mean, there can be code changes required there. So as part of the tuning activities, you can use tools like Dynatrace to find out which objects are basically taking more time, and then from that you can analyze I mean, which at code level what changes are required, or if a particular SQL query is taking more time. So those, and then from database side, the DBAs can fine-tune those queries as well as update indexing or perform database tuning on that. From server performance, we can do, we'll go over the following slide on the different server performance tuning we can perform, as well as you can also use several WebSphere tools to find out if there is any memory leak on the viewing the Java course and garbage collection data. So these are some of the properties from the server side you can fine-tune. The JVM properties, the minimum maximum heap size, garbage collection, class loader options, and then the queue settings also you can update, such as the thread pool, EGB pools, JDB connections. These are some of the properties from the WebSphere side. You can update network setting, database tuning, JMS messaging, operating system tuning, CPU, hard disk. So these are some of the tuning we usually perform. As part of the caching, there are two types of cachings. One is static data caching and the dynamic caching, which is all your servlet and JSPs which are cached. So these are the caching. Dynamic caching basically allows all your requests to be served by the cache instead of going to the server. As part of the requirements gathering, as part of the caching strategy, it's important to get requirements on your caching. Discuss invalidation requirement scenarios, test for exception and privacy scenarios, making sure nothing unexpected is cached. Create cache-specific test scenarios that are different than functional test cases. Monitor cache status in both the QA and lifecycle. Tuning. So these are some of the best practices from caching perspective. There's a caching extended monitor available, which allows to check the cache hits. This is to verify that the objects are getting picked from the cache. So this is one of the analysis step. So as part of the performance methodology, we basically identify the workload, do the analysis phase, and then perform tuning for at different levels, the system level, application, and programming level. So the and then as part of the some of the tools which are used are so for testing we are using RPT and Dynatrace and similar monitoring tools have really helped monitor different layers here. So as part of the other after your so in the production environment, the other monitoring you can do is if your site is you can do proactive monitoring by making sure if your site is going down or if the response time is slow, you can create automated scripts to check that would be run every frequency of 10 minutes or so. That will check the response time, if response time on your site, and if the response time goes down, if the response time increases, it will alert your support team to check on that. So that's also one of the some of the good tools you can use for monitoring. There are tools like Uptime, Prong available, which can provide dashboards as well as alert emails when the sites are not slowing down. The other best practices is to automate all your change management process. This also this basically reduces manual deployment issues and speeds up deployment and reduces downtime. So the tools which are available to automate are there's udeploy, build and udeploy, and the WCBD out of the process for commerce applications. WCBD is ant-based. You can customize all your scripts such as restarting of the server or any other scripts which you run as part of the deployment. These are some of the best practices. From the case studies perspective, Office National is one of our clients in Australia where we did the similar exercise. They were having performance issues and from the total browse response time before we did the load testing, the initial time was around 20 seconds, and the first byte time was 5 seconds, which was the server response time. And after all the fine tuning, that the server response time went down to 0.9. So this is one of the test cases, and then Apple Vacation is one of the other client where they were having issues with the performance issues like hanged threads, out of memory exceptions. So here the team basically used different IBM provided tools to analyze the issues in the production, like thread dumps, heap dumps, and from that we found out that some of the objects were taking more time to some of the utilities, Java utilities were taking more time to execute. So we had to update some of the code there, and then some of the JDBC queries were taking more time. So that was causing the database use time to increase. So we found out that the database DB maintenance scripts need to be run and executed on the database side. So those we had to do some database maintenance tasks on a weekly maintenance tasks. After that, it improved the database response time, and then the thread issues were resolved. So this example basically shows one of the snapshot of the Tivoli performance monitoring tool. This basically brings us end of this presentation. If you have any questions, please add that in the chat, and I will try to answer.